Hi everyone, this is Miss Schneider. I'm the other Honors Algebra 2 teacher. I know you haven't heard my voice before. I'm giving my first shot at a video on this one. So what we're going to talk about today, our objectives, are to explore some of the other transformations of some different parent graphs. So we've talked a lot about the parabola and how we can move that to stretch it, compress it, shift it left and right and up and down, and also flip it over. So we're going to talk about two other parent graphs together. You're going to investigate one on your own, and then tomorrow in class, when you have that block day, you're going to do the fourth one. And you should have some Cornell notes that look a little bit different. I'm going to refer to that as your toolkit. So we're going to be filling that out. I'm going to talk about how you can shift those around, the different parent graphs, and then we're going to be filling out the toolkit. So we're also going to talk about some general forms for each of your parent graphs. And so yeah, let's get going on that. First, I want to review kind of what we talked about with the parabolas. So if you look on the top here, I've got this general form written, which could be either a positive or a negative a times x minus h squared plus k. Now if you remember, that plus or minus at the front either flips our parabola or it will make it look up and down like this one here. That a value will stretch it. If that a value, is bigger than 1, it'll stretch it so it looks like silly putty. When you pull it up, it'll look skinnier. That graph will. If that is a fraction or a decimal between 0 and 1, it'll compress it and make it look really fat. That h value up on the top, remember, moves our equation left or our vertex left and right. So if that says like x plus 2, we're going to be moving to the left actually. And if it says x minus 4, we'll move to the right 4. So it's a little bit backwards of what you might think. Then lastly, remember this k value over here on the right tells us if we're moving up or down. So like a plus 2 would move us up 2, and a minus 3 would move us down 3. Okay, so that's the general form of a parabola that you should be pretty familiar with. What we're going to do now is investigate y equals x cubed. Now this is a cubic function, so it's going to be pretty similar to our parabola, except let's take a look at what this graph looks like. So it looks like a parabola, except that left side is flipped down. The right side still kind of looks like a parabola, except that left is flipped down. So let's talk about how I could move this graph around. It's going to look pretty similar to our parabola. We move it left and right by the same way. So if I have that x minus 2, moves the center of my cubic function 2 units to the right. And if I've got that x plus 4 in parentheses, it's going to move that center, which is now on 0, 0 in the graph, right over here. You'll notice that if I put my pointer right here, I'm looking at 0, 0, it would move that 4 units to the left, to there. Okay. The other thing we can do is we can move it up and down, and it happens the same way. If I have that plus 3 after my x cubed, it'll move it 3 units up. So it'll go from right here where it's at, it'll go 3 units up. And if I have x cubed minus 2, it'll take it 2 units down in the center. The other thing we can do is we can stretch this vertically, and we can compress it vertically as well. It's going to be the same way with that a value either being a number greater than 1 to stretch it, or a fraction between 0 and 1 to compress it. And we can also flip this. Okay, now when we flip it, it's not going to be all pointing up or all pointing down like our parabola, but then this left side would go from the bottom up to the top, and our right side would come from the top to the bottom. So our graph instead, if you look at my little cursor, is going to do something like that. Okay, hopefully that made some sense. Now what I want you to do on your Cornell notes is in that little toolkit spot, fill this out with me as I talk about this. So this is the cubic function still that I was talking about on the last slide. But go ahead and fill in the name is cubic up here, so go ahead and write that in. And our parent equation is y equals x cubed. Now if you look at this general equation, it's going to look really similar to your parabola, and you might even want to, I didn't write here, but if you want to add in a plus or minus in front of that a, go ahead and do that. That's going to tell you if we're flipped or not. So you want to add in that plus or minus a times x minus h cubed plus k. Now we're going to talk about some of the properties of this function, and what I want to show you is that there's always going to be one x-intercept and one y-intercept, and no asymptote. So if you remember, back when we were investigating functions in Chapter 2, you'd have to tell me if there was an asymptote or not. Or maybe that was chapter 1, I can't remember. It's a long time ago. But we would always talk about asymptotes. Now this function is not going to have one because I don't have anything under a square root. I don't have anything in a denominator. So there's no x value that's off limits for me. So go ahead and fill in that there's no asymptotes and there's always going to be one x-intercept and one y-intercept. Let's make this table and graph. Okay, and we'll talk about the domain and range. So go ahead and fill in this table like I did up here. And draw yourself a nice little picture on your toolkit. If you need to pause to copy all this stuff down, go ahead and do that. And my domain, if you notice, this function goes on forever to the left and to the right. It also goes on forever down and up. Okay, so my domain and range both are all real numbers. They go from negative infinity to positive infinity. Because of that, I'm going to cross the x-axis one time, and I'm going to cross the y-axis one time. Now where that happens kind of depends. It depends on where that center point shifts to. Now, we're going to talk about h comma k. So if you look at the general form of the equation, we've got h over here and k over here. If you put those two in an ordered pair, just like we could talk about the vertex of our parabola, we're going to talk about the center point. And that happens right here. You also might hear that be called an inflection point. It's where the graph kind of goes from concave down to concave up, and we'll talk about that later on, so don't worry about that. But that center point is right there, and that's the point that we're going to be moving around. Okay? So go ahead and make sure that is all filled in, and then we'll move on to the next parent graph that we're going to talk about. And the next parent graph we're going to talk about is the equation y equals 1 over x. Okay, now you'll notice some patterns as I start talking about how we can shift this around. But the center point of this graph, which we call a hyperbola, is located right here. And we'll talk a little bit more about that when we go to the toolkit later on. But that center point is right here, and that's the point we're moving around, okay, is that center point. So we can move this whole graph left and right, okay, by replacing that x in the denominator with x minus h. Okay, so if I do x minus 2, I'm in my denominator, I'm moving this whole graph 2 units to the right. Same idea, if I have x plus 4 in my denominator, I'm taking this whole graph and moving it to the left 4 units. Okay, we can also move this up and down, just like before. And that happens if I have my 1 over x as a fraction, and then outside of my fraction I add 3. That would move it up 3 units, and if I, outside of my fraction, subtract 2, that would move this whole graph down 2 units. We can also stretch this vertically, and we can compress it vertically as well. Okay, so we can make these two sides of our hyperbola stretch out or compress down. And as we play with these a little bit, you'll kind of see how different numbers make that look in your graphing calculator. In fact, if you want to pause and go ahead and experiment a little bit with that, feel free to do that now. So if you look, I wrote this as 4 times 1 over x. You could also write that as 4 over x. And I wrote the compressed one as 1/3 times 1 over x, or 1 over 3x. And that's just simple fraction multiplying that I'm doing there. You could also flip this so that instead of working in quadrants 1 and 3, my hyperbola would be in quadrants 2 and 4. Okay? Now go to your toolkit, and we're going to fill this in. So go ahead and write the name, which is hyperbola, up at the top. The parent equation is y equals 1 over x. And then go ahead and fill in your table, noticing that at my x equals 0, my y is undefined because I can't divide by 0. Okay? So then go ahead and use that table of values to fill in the graph. You can pause this if you need to catch up. But I'm going to keep going. Now the general equation of this is going to be y equals a, and again feel free to add a plus or minus in front of that a times 1 over x minus h plus k. Now your properties is you're always going to have an asymptote, okay, that is at x equals h. So it's going to be this vertical line at x equals h, and in this parent graph our h is 0, so it's x equals 0. And you're always going to have an asymptote at y equals k. And right now I'm running my cursor along that asymptote, and because right now our k in our parent graph is 0. And the description of h, comma k, is going to be that point where our asymptotes intersect. Okay? So right now our points are intersecting at 0, or our asymptotes are intersecting at 0, 0. So that's the description of h, comma k. And it's not a vertex in this one. So it's just going to be a point where we don't actually have any dots on our graph. It's just going to be that center of our graph. Okay? And I did forget to write on here the domain and range. Okay, so the domain is going to be all real values except x equals h. Okay, it can't be x equals h, which you'll notice from the asymptotes. And the range is going to be all y values from negative infinity to positive infinity, except y equals k. Y cannot be k. So go ahead and make sure that you fill in those domain and ranges yourself. Now on the last box on your toolkit, on your Cornell notes, you're going to fill in and investigate the equation y equals the square root of x. Go ahead and give it the name square root, and the parent graph, the parent equation, is this y equals square root of x. Okay, so what I want you to do is go ahead and fill out that graph, try and tell me what h, comma k is, give me any properties of this equation, and we'll talk about that in class tomorrow, but I want you to come having your toolkit as filled out as possible. Hope my first video was a success, and I'll see some of you in class tomorrow.